All right, today we're going to work on lesson 5.9, understanding an algorithm for fraction multiplication. So we're going to use area models to understand and apply an algorithm for fraction multiplication. We want to be able to apply and extend previous understandings of multiplication division to multiply and divide fractions. So let's start with our warm-up. Okay, it tells us to round each number to the given place value. So let's look here. Our first one says to the nearest whole number. So I look at the whole number, which is to the left of the decimal. It's 6. And then I look to the right and I see in the tens place it's a 1. So I'm going to round to the nearest whole number. I'm going to actually round down. It's closer to 6 than it is 7. The next one here, it tells us to round to the nearest tenth. So again, pay attention to the fact that it has the th at the end for tenth. Okay, so look at the tenth place and to the right. If it's 5 or if it's 4 below, then I round down. In this case, I'd round down to 6 and 1/10. And then our last one here says round to the nearest hundredths place. So I go to the hundredths, and I see to the right it's 0, so I'm going to round down. So it'd be 6 and 14 hundredths. And so you can go through and do that for the next set. Same thing, whole number 10th, hundredths, so make sure you pay close attention to that. Okay, in this one, the whole number is 0. The 5 tells it to go up, so the nearest whole number would be 1. The next one, to the nearest tenth, the 8 tells the 5 to go up, so it becomes 6/10, and the rest of that would drop off. And then same thing for the hundredths. I could go to the hundredths place. The 6 tells me to round up, so I round up to the next hundredth, 59 hundredths. So then an algorithm is a set of step-by-step instructions for doing something such as carrying out a computation or solving a problem. Now, work with a partner to draw an area model for 3/4 times 2/3. Look at the journal, page 177, to help you. So we did this in previous lessons. So you may not have a partner, so just pause the video and do it on paper. Okay, so let's go ahead and look and see if your fraction model matches up to mine. So I have 3/4 multiplied by 2/3, or I could say 3/4 of 2/3. So I know from the previous lesson, I'm going to do the second fraction first. So I split it into thirds. And then it tells me to shade in 2/3 of that. So I'm going to shade in 2/3. And then I look over here, and I know I look at the first fraction's denominator, and it tells me to split it into 4. So 1, 2, 3. And then it says the double shade 3 out of 4. Okay, so I see I have 1, 2, 3. And then there's a group of 4 here that is shaded. So I'm going to shade 1, 2, 3. And you can see here I got a little bit crazy with my shading. Fix that. Okay, so you see I have 1, 2, 3, 4, 5, 6 out of 12 pieces. And there's 1, 2, 3, 4, 5, 6 left over. So again, you want to be careful with your shading, do a little bit better job than I did there. Otherwise, you could mess up your shading stuff there. So let's look at it here. Okay, so here's a cleaner example of that. So it should look something like that. Again, mine looked a little bit different, but it still covered the same amount of 1, 2, 3, 4, 5, 6 twelfths. So how would you mark the number line to help us draw a rectangle as 3/4 by 2/3? So you can see here you do thirds, and then you would do fourths. Okay, so again, you may not have a partner with you at home. But go ahead and take a minute, do 1/3 times 3/5 as an area model. And so you can see here, we have this. So I look at the first fraction, and I have a third. So I want to try to split it evenly into thirds. So I have 1/3, 2/3, and we know 1 whole is 3/3. The second one is fifths. So let's see, 1, 2, 3, 4, and that gives me fifths. And you want to try to get them even as possible. Didn't do a great job there. You could even measure them out if you really want it to be 100% accurate. Okay, and I look at the second fraction, it tells me 3/5. So I'm going to go over, draw my grid in here, to 3/5, and I'm going to shade all the way over to 3/5. Okay, so I got that checked off. Now it tells me here to go up 1/3. Now, I already went up 1/3, and so we can see there I now have a 3/5, which gives me 15, and my shaded parts are 3. So if I double shaded those, I would have 3/15. Same thing as just multiplying straight across. And again, you have another one here you could do, 5/6 multiplied by 2/5. So take a few minutes. You can do that on paper there. So again, I'm going to split it into 6, 3, 4. And so you would just go through label 6. And then here you would label 5ths, and then you would do your shading. After you do your shading, it should match up to the multiplication here. If we do 5 times 2 is 10, 6 times 5 is 30. When you look at those two, it should match up. So you should have 10 out of the 30 pieces shaded. Okay, so it says draw an area model, represent, and solve the following. So 4/5 by 2/3 and 2/4 by 1/5. So do that on paper or your marker board at home. And so we'll do one more here together. So we'll do this one, 2/3. So I'm going to do thirds first. I'm going to say 1, 2. So I have 1/3, 2/3, and we know 1 is 3/3. And let's see, fifths. So 1, 2, 3, 4. So 1/5, 2/5, 3/5, 4/5. Okay, so I'm going to look at the first one after I make the grid here, and then I'm going to shade in 2/3. So it says shade over 2/3, so I go over to 2/3, I shade it in. Now it tells me 4/5, so then I go up 1, 2, 3, 1, 2, 3, 4, and I shade in. But I need to shade in all the way over to 2/3. Okay, that's the key there. All right, I'll use a different color so you can kind of see there. So we have 1, 2, 3, 4, 5, 6, 7, 8 out of 15. So 8/15. So my number sentence simply would be 4/5 multiplied by 2/3 equals 8/15. So the second one, after you do the model, you could check with multiplication. You should have 2/20 shaded in. So remember to make your labels, do your number sentence, and your shading. So examine the denominators of the factors in the total number of parts in the area models, and look at the numerators of the factors and numbers of shaded parts in the model. Do you see any patterns? So what is it that you notice? Do you notice anything there? So why is the pattern the same for every problem? So where does the total number of parts in the square show up in your answer? Okay, the total number would be in the denominator, right? And the shaded part is your numerator. Remember, the numerator of a fraction is parts. The denominator is the whole amount. So we can use this information to think of an efficient way to multiply fractions. So we know we could multiply the numerators and the denominators. And so we don't want to have to shade for every single fraction, so that's why we have an algorithm, and you can read through there, that will be much more helpful for what we're trying to do when we're multiplying fractions. So complete problem 1, Math Journal 2, page 179. So go ahead and pause the video, complete that. Okay, so hopefully you've already answered. Here's a sample answer. So in your own words, describe the method for multiplying fractions discovered in class. So a sample answer, again, you want to have your own thinking, but you can compare it. To multiply two fractions, multiply the numerators and write that as the numerator of your answer. Then multiply the denominators and write that as the denominator of your answer. And you could even do a number model to show it there. Okay, so go ahead and pause the video, complete Math Journal 2, page 179. So work on the rest of that, come back and we will go over it. All right, so hopefully you've had a chance to look at this. So let's just go take a peek at it. So it's not asking us to simplify. just asking us to use the algorithm. So that means we don't have to use the area model. We're just simply multiplying straight across. So when I look at this one, I know I'm just doing numerator times numerator, denominator multiplied to denominator. So 1 times 3 is 3, 2 times 3 is 12. Okay, and I get 3/12. So that's what you're going to do there. On number 8, it asks you to draw an area model for one of the problems. Explain how it shows your answer is correct. So in this case here, you're going to do the area model, just like we practiced. And so you're going to pick one. You want to make sure you label it. So like if I did 3/5, if I chose number 4, I would label it with fifths, and then 6th, and then I would label and shade to see if I got the same answer as my product. So again, just multiplying straight across. And you could check your answers against this. Make sure you've done the work beforehand. And this is just a sample problem. So if you did problem 2, confirm there, but you can see there what you need to do. So these are not in simplest form or lowest terms. So just multiplying straight across right now. Now let's look at the story problems. We want to make sure we're using cubes, even if you're at home and someone's not watching right over here, to make sure you're doing that, because it's helpful on figuring out what you need to answer. So I can see I need to find the number model. I need to find the answer. They already give me the units, so that's helpful. So it says Sheila had 3/4 pounds of blueberries. So I'm going to circle that number. That seems she used 1/3 of them in a fruit salad. How many pounds of blueberries did she use? So I see 1/3 of 3/4. So I remember the 1/3 of 3/4. And I know that when I find a fraction of a fraction, it just simply means to multiply. So go with a different color here. So then I would multiply straight across. So let's check your answer with what we have here. Okay, so you should have a number model of 1/3 multiplied by 3/4 equals R. The R could stand for blueberries or fruit salad. You could have done F or B or any letter to represent the unknown, okay, which would be the answer. And then 3/12 pounds is how much she used. So let's look at the next one here with cubes. It says the mirror in the dollhouse is 2/4 inches wide and 3/4 inches tall. What is the area? Okay, when I look at this, I see area, and I know the area is length times width equals the area. So I know, again, I have a multiplication model there. So think about what you would be doing on there. So you should have already completed this. And you get 6/16. And again, they put A for area. You could put whatever variable. You could put I for inches or S for square inches. And then look at 11. Ben tried to solve problem 9 and got the answer 4/7. He said that can't be right because it's 1/3 is less than 4/7. Do you agree with Ben? Explain. So when you think about that, do you agree with the answer that he got for 9? Okay. If not, explain why you do or do not agree with Ben. Okay, and then there's home link page for some extra practice there, but that wraps up this lesson.